Okay, so anybody, I mean, in layman terms, can you tell me what does it mean to you? I mean, you must have heard this humidification, you know, much before this class, right? So in layman terms, what does this give you, or what does this tell you, or what do you feel about humidification? When we all are aware of humidity, right? That we know around us about this, how humid is the weather. I mean, mostly we talk about humidity in terms of weather conditions, right? How humid is our weather, or what is the humidity, relative humidity and all. But in general, what do you feel about I mean, what do you understand about humidification? Anyone? Please feel free. I mean, the more you are open, the better we can have this live interactions. So anyone, what do you feel, or what do you understand by the term humidification? I mean, this is not a new term to any one of you, I believe. It's a term that you have been hearing for the last couple of years, I guess. Right? So what do you mean, or what do you think about humidification refers to? Oh, come on. Adrija?
Yes, sir. Sir, it means to make dry air wet by dispersing water droplets, like when we turn on the cooler.
Okay, interesting. So you mean to say cooler humidifies the air? That is true, but the primary purpose is to cool. Anyway, that
Yes.
is one way of seeing at things. Any other view? Anyone? Shayon?
So it is, I guess, like we make any dry object wet by some chemical processes.
um, a dry object to become wet. Okay,
In
by
dry materials.
okay, okay. Anybody else? Any other
So
different view?
it's constituting the water vapor into the gas
So,
by steam, by passing through steam.
so what do you mean constituting the water vapor in gas?
Sir, by if we pass the air through the steam, then water vapor droplets when enter the gas molecules and made the air humid.
Sir, increasing the water content of the gas or anything that we are concerned about, right?
Okay, okay. Lot of different views. Interesting. Any other? It's nice to hear your views because it often gives you a different way of seeing at things. Anybody else? Come on. I do not want to just call you out your names. Feel free to participate, in the discussion. We're not talking about rocket science at the moment, so I mean, it's just layman things. No? Any other different view that you feel? One general point that I would make here, is it always related to water vapor or moisture adding into gas? Or when we say that trying to make things wet, from dry to wet, is it only addition of water or water vapor or moisture to that object? Can it not be something else, or what do you think about it? Or do we not call that as humidification? Hmm?
Sir, I think it should be related to water because when we define terms like relative humidity,
Mm-hmm.
we always talk about its relative to water.
No, no, that is okay, but I'm thinking, I mean, you are correct that when we talk about relative humidities, we try to make a comparison with a fully saturated condition. Let me put it this way. right? But the question is that do we always mean it to be water or water vapor or
Um,
moisture?
the term itself is humidity. Humidity is the water vapor content. So
Mhm.
humidification is obviously increasing the water vapor content in the gas, maybe.
Okay, okay. So here let me slightly, let me intervene and correct, or just have a place a different viewpoint, I would say. As most of you have tried to say, humidification is the process of, addition or incorporation of, water or water vapor or moisture into a gaseous stream. That is it's correct. It's not that it is not correct, it is correct. But this I would like to have a more generalized view of humidification, in the sense that it is the addition of not water vapor but any vapor to a gaseous stream, right? It could be any solvent, and that is actually true. So humidification in a generalized perspective means that addition or inclusion of any, vapor content. It could be any solvent. You could add ethanol vapors to air, and that would mean that the air is still humidified, of course not by water vapor but with ethanol vapors. Or addition of any other, mostly organic solutes are organic solvents are, quite known for their high volatility, so they constitute a considerable amount of the vapor pressure. So any vapors which is present, or any, you know humidification operation can involve any solvent vapors and not only restricted to water vapor, right? So this is the generalized view that I would like to, extend your explanation or thoughts, right? The other important point, or let us say the engineering view of humidification, is that this process of incorporation or addition of this moisture or any vapor content to air should be done without the change of its temperature, right? That is what we typically call as a humidification process. So this is more of engineering view, as I say. In real life this never happens. Always addition of this moisture vapor, water vapor, always involves some change in the temperature, right? So there is this change in the temperature associated with the humidification process. But if you just want to call as the, the definition of humidification, then it must be mentioned that it's a process of addition of, vapor, water vapor, moisture, or any solvent vapor for that purpose, at the constant temperature of the air, right? So during this process of addition should not involve change in the temperature. That's how the humidification process, or classically the humidification process, is defined. Okay, so having said what is humidification, the next quick question that comes in, or the quick thought that comes in mind, what is dehumidification? Of course, this goes without saying that this means just the reverse of humidification, or removal of the vapor or the water vapor content from this air stream or from air. Can anyone tell me some real applications or real life situations where we have this dehumidification?
So for finding dry wet,
Finding dry wet.
I mean dry wet of things.
No, please let us not confuse ourselves with dehumidification and drying. Drying is a bit different, and generally drying we mean for solid materials, removal of moistures from solid objects. But dehumidification is mostly removal of water content or solvent vapor content from airstream. Okay, so can you tell me an application where dehumidification is used? Come on, it's
So
not too
can we say
difficult
that
to think.
Can we say that
Yes.
placing silica gel in things to prevent them from getting like moist and getting destructed can be dehumidification?
See, we generally used silica gel to remove moisture from the air stream. It essentially dries the air, but since the moisture is removed from the air, we can call this as dehumidification. Anything else which does not involve a solid object. I mean, this is
Sir,
true,
So like
again,
in a
you are right, but
humid room,
yes.
so while there is a lot of humidity in the room, we normally turn like AC so that we, remove the humidity in the room, something like
Okay,
that.
so just thought like what do you feel that how AC can remove the moisture? In what way? It doesn't
So
contain
like
silica gel.
it shows the dry, cool air, and
Yeah, so the
it.
point, let me catch you there only, that how it produces dry air. How? It doesn't have a air cylinder, neither it has a silica gel, isn't it? So that it
So the
can pass the.
condenser is there in there in AC. Like there's some
Condenser is
machine that.
there to cool. The condenser is there to, so all of you are aware of this function of the AC, right? That it compresses and decompresses the air, and during not air, this cooling coolant fluid, and during this process the, I mean, during free expansion, this coolant fluid cools down, and then you make it sort of works as a heat exchanger. You exchange that heat, you transfer that, or you remove that heat from the air, it cools the air. But how does it dehumidify the air? It's very interesting. Dehumidification of air by an AC. It does. It's not that it doesn't. It does. But not all ACs does, but it does. The question is how. One easy way of dehumidification is to heat the air. Right, of course this doesn't happen in an AC, is to heat the air. What happens during the heating? If you heat the air, the capacity of that air to hold more moisture increases, and so what does it mean? The saturation limit increases if you increase the temperature of the air. Right? We'll talk more in details, but just I'm trying to give you a heads up that if you heat the air, if you increase the air temperature, its saturation capacity increases. Right. So having said this, the saturation capacity, the present moisture content, then whatever is available at that point, and the temperature is increased, so essentially the relative humidity of that air decreases. Why? What is relative humidity? I mean, most of us are aware of that it is the ratio of the current humidity with respect to the saturation humidity, or the saturation capacity of that air to hold, isn't it? That's what do we mean by the this relative humidity, right? So now the question is, now the idea that quickly comes to mind, that if you heat, the saturation capacity also increases, so the essential or the effective relative humidity decreases, so the air feels to be more drier. So this is one way to dehumidify air, just to heat it. But in AC we doesn't heat, right? So then how does an AC dehumidify the air?
Sir,
Yes.
like I have a question. Uh, does the word humidification is only defined for air, not for
No.
any other?
No. As I said in the beginning, I think you joined later. So humidification, the word humidification has a broader meaning, or it's more generic towards any vapors, not only for water vapor, for any vapor that gets into, or that is added to the airstream. Right? It could be any solvent vapor. This is what I just said.
Like
I mean,
we
it's,
can add any vapor, but we have to add it in air only.
yes.
So it is defined for air.
I would not say, again, let us be more generic. It's not also for air, for any gas, I would say, right? But mostly it is the air that most applications are based on. But yes, making an extension to this explanation, it is for any gas. So any solvent vapors or any vapors added to any gas can constitute or can be defined as a humidification process. Okay.
Sir, what is the difference between dehumidification and drying?
Yes. So drying involves removal of moisture, right? Or for example, again, any vapor content from a solid object, essentially. Dehumidification is the removal of the vapor content, or if you are talking about in terms of water moisture content from air or from the gaseous stream.
So how would that heating
Okay, sir.
example fit into your definition of dehumidification? Because in that we are not removing any water vapor content. We are just reducing the relative humidity. So how would
Yes,
that fit into the definition?
yes, excellent point. So when I talk about increasing the air temperature, right? Increasing the air temperature means the humidity content doesn't decrease, right? But it's the relative humidity that decreases. So if the relative humidity decreases, the air, think in a different way, the air has more capacity to hold more moisture. So we are enhancing the limit or the capacity of that air to have hold more moisture. So in a different way, I mean in a reverse way, as we say that dehumidification is of course removal of moisture, but in this case instead of removal of moisture, what we can also say that the if I consider two airs having same levels of humidity but at different temperatures, right? The air which is at a higher temperature has the capacity to hold more moisture, right? So if I try so the idea that comes to the mind at the point that I want to make here is that even though the levels of humidity are same, the air at a higher temperature we can hold more moisture because its saturation capacity is now increased, right? So to that, I mean in that you can say that the relative humidity of the air at a higher temperature is low. So the air, if we want to, so when we try to do a dehumidification operation, the idea is essentially to reduce the moisture content or to reduce their relative humidities in whatever way, so that the capacity to hold moisture for that air increases. Why do you want to dehumidify our air? It's that or that gaseous stream, so that it can absorb or hold or take up more moisture, right? That is the purpose of doing a dehumidification operation mostly in an industrial setting, right? So that I mean what does it makes us to really feel like we have a dry environment? It is something that the air is really dehumidified or the relative humidity of that air is low, or that air can take up further moisture and make our environment or surroundings more dry, right? Now if the capacity of that air is increased, it will have the ability to have or hold or take up more moisture, right? So the need for dehumidification of that hot air is reduced because it can hold more moisture. So that is like just saying it in a turnaround way, that the air becomes more dehumidified because it has more capacity to hold the moisture even without removing the existing moisture content. To some extent, is this make sense? So one way, I mean, I hope we are connected. Suddenly, it feels like I'm lost. Are we connected? Can all of you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So I hope whatever I just said, it made some sense. So coming back to the this point on how does this air conditioner dehumidify our air is that if you decrease the air temperature below the dew point, We'll talk about what is the dew point. But at least I can say that dew point is a temperature below which at which the temperature or this water vapors becomes saturated at that temperature. Right. So all of you are aware of this saturation capacity of the air with respect to the temperature, or the vapor pressure of the air with respect to this temperature. So the dew point is the temperature at which the vapor in the air condenses. Right. I mean, in the in really cold winters, you will see this fog forming. So when the air temperature or the environmental temperature drops below the dew point, the moisture content in the air form droplets or it condenses, right? And it no longer stays in the vapor form in the air. Instead, it forms small liquid like dew droplets. So that is generally the dew point. We'll of course talk about these dew points in much more detail. So when the air temperature is below the dew point, right, this a part of this humidity or this water vapor content or moisture will actually form droplets, and that will be removed from the air. So it will then become a two-phase system. One is the gaseous stream and one will be the liquid droplets. So the condensed liquid droplets will be removed from the this air stream. And now if you take that air temperature back, if you take that air temperature back to a slightly higher level, the net humidity content or the moisture content is now reduced, right? And the air will feel more drier, right? This is how this operation is done in the AC. So let us say your outside temperature is 40 degrees, you want your AC to be at 25. Now whatever is the outside air humidity, let us say the dew point is around 20 degrees, right? So you cool the air from 40, or you try to bring the air temperature close to 20 degrees, right? So that it reaches at the dew point, right? And this, by the condensation, some amount of water vapor is removed. Then you slightly heat it to 25 degrees, right? And now you get a temperature air at 25 degrees, but which is a lot dehumidified, right? If the dew point comes to be above 25, it's well and good. You need not to do any kind of reheating, small reheatings, right? Because that costs a lot of energy to bring it down to 20 and then again reheating it up. But I mean, generally it is not favored. I mean, most ACs are designed in that way that it doesn't decrease too much below the set temperature, right? So in most cases, only if it is comes closer to the dew points come closer to the set point temperature, this dehumidification works very well, right? And that is true because most humid air will have, I mean, if the air is very humid, and that's when you need the dehumidification operation in the AC, right? The dew point temperature will also be larger, right? Will be more. So easily the air can be dehumidified by this, condensation by lowering the temperature. Okay, so we will do some one or two problems related to this also, and it will make our idea more clear. Okay, so I think by now all of us are well conversant with the applications of humidification and dehumidification. One thing that I would like to highlight, in most apart from this drying operation, that generally dehumidifier is needed. So why do we need a dehumidifier? You generally want to, let us say, want to dry a wet solid, and in that case you need a dry air. So how do you produce a dry air? It is by a dehumidification operation. When do we need humidification operation? Is like if you want to I mean, when does a humidification operation happens is, again, I think one of somebody has said in the beginning, when we try to dry, or when we try to dry a wet object, the wet object in the process of getting dried, the surrounding air becomes humidified, right? So again, in a drying process, humidification is involved for the gaseous stream. One of the biggest application of this humidification process is the cooling towers. So what is this cooling tower mean? Is that you have water and you try to evaporate the water. During the process of evaporation, the surrounding air becomes humidified. But since during this evaporation process, the water loses its latent heat, so the water temperature reduces, right? water temperature reduces, and this is a very important operation because in an industrial plant you always need a supply of cold water or cooling water, right? All of you have heard about this need of cooling water. For most heat exchangers or heat recovery systems, you need this cooling water, right? So how this cooling water is produced? It is not produced in a chiller, right? Most industrial applications in cooling water, unless it is needed, temperature is needed below the certain range of the temperature, in most cases the cooling water is produced by this evaporation process, and this is the intense humidification operation, because in this process the air gets humidified, and the limit to which the water temperature can be reduced depends a lot on the surrounding air humidity. So we'll of course talk about these problems a lot, but I just want to highlight at this point or in the first class today that cooling water towers or this cooling water operations involves a lot of theory of the humidification operation, right? And this is a very important part in almost any process industries, because you need a constant supply of this cooling water. And also you will see that cooling water available in our country is generally at a temperature of 30-35 degrees. Whether in other cold climates you can obtain cooling waters at almost 15 to 20 degrees also, because it also depends a lot on the air temperature, air moisture content and all, right? So we will talk about all these details in the first class. Just I want to highlight the different aspects of humidification and operations and its application and what do we mean. Achha, let me just define or mathematically let us state what do we mean by humidity, or how humidity can be quantified in a mathematical expression. So when I say humidity, I mean absolute humidity. So let us define this in terms of Y as absolute humidity. So as I said, it is the vapor content in a gas, right? So Ya is the these two are the mole fractions. Let us say in terms of the moles, if I are trying to define these two, this would be the ratio. This would be the ratio of the mole contents of this component A in component B. Of course, component A is the vapor and component B is the gas, right? So having said this, it can also be defined in terms of the partial pressures of A and B, right? So these are the partial pressures of this component A or the vapor A in gas B, and if it is only only one vapor that we are dealing about, we can also write this in terms of PA by PT, that is the total pressure minus PA. Right, so essentially this is nothing but the moles of A, which is you can say in terms of the vapor, divided by moles of B, which is of course the gas. So in most cases the vapor is the water vapor and gas is the air, but this is just the generic expression, right? For humidity, this is defined, I mean this humidity is defined in terms of the mole basis. You can also define in terms of the mass basis. Let us say I call this this mass, so this is in terms of the moles, ratio of the moles. You can also define in terms of the mass. So in terms of the mass, this molar humidity would be multiplied with the molecular weight of A divided by the molecular weight of B, right? And this would essentially gives you mass of A per mass of B, right? So if you are talking this in terms of water vapor, so this would be kg of water vapors in kg of dry air. This is very important, huh? Not air, dry air. So of course you can easily relate that if you are talking about A and B to be, air water system, then A becomes the water vapor and B becomes the air. So air means dry air, so air devoid of that water vapor, right? Because we are talking about the partial pressure of the dry air, not the air containing the water vapor, right? So this is how we generally define the humidity. It is the ratio of the moles or the mass of the vapor in the gas with respect to the gas. If you're talking in terms of the molar, stuff, you can always define this in terms of the partial pressures, right, following Dalton's law. And of course, if you multiply that with the molecular weights, that will give you the mass compositions, right? So one general simplification that often is done is that uh, this so this part, generally this PT is much greater than PA. So this part can be, so this part can often be simplified to like this, because PT can be, generally it is much larger than PA. Is this clear? Absolute humidity. Anyone has any doubts on this absolute humidity? So if we are sure, if we are, confident on this absolute humidity, let us define one more thing. What do we mean by is going on? What's wrong? So another important quantity that is relevant here is the saturation humidity, right? So what do we mean by this saturation humidity? The saturation humidity is the amount of water vapor, or let us say the vapor present in the gas or the air stream, beyond which it cannot any longer hold that vapor content or the moisture. In terms of the partial pressures, so I would say these to be that this is the condition, or this is the air becomes completely saturated with the water vapor or this vapor at that level of the humidity, right? So at the humidity or at the saturated condition, the vapor pressure of this uh, this water or the moisture will be equivalent to its vapor pressure. Now I hope all of you are aware of this. What do we mean by this vapor pressure? The term vapor pressure, recalls or comes into the mind when we try to define boiling. So boiling is the temperature at which the vapor pressure is equivalent to the ambient pressure, right? That is where we first hear the vapor pressure. So here what I'm trying to say is that the vapor pressure of this, the air becomes saturated is because when the partial pressure of this vapor present in the air, or this water vapor present in the air, is equivalent to its vapor pressure, right? I don't know why I can't scribble here now suddenly. So far it has been going well. Writing pad doesn't seems to function properly.
So could you repeat the statement in terms of pressure?
Yes. So when the partial pressure is equivalent to the vapor pressure at a particular temperature, we say that the air becomes completely saturated. Okay. Now, if you think of this to be saturation due to the, let me close this. If you think this to be the saturation in terms of the water vapor, so what I say that when the partial pressure of this moisture is equal to the vapor pressure, then the air becomes completely saturated. Let me try it once again. So saturated air, let us say we define this in terms of Ys and in terms of mass quantities. So saturated air, instead of PA, I will write it to be PAV, that is the vapor pressure. Right, and all of you know how we can obtain this PAV. Either you can look into some hookup charts, or you can always have this, sorry, Antoine's equation, right? So all of you are aware of this Antoine's equation that is generally used to calculate the vapor pressures. Something like this is it, where T is in Kelvin, right? So this is how we generally define. Of course, this has to be multiplied with the molecular weights of A and B. Right? So this is how we generally define the saturation humidity. So at any point of time, at a particular temperature, the humidity levels or the humidity cannot exceed the saturation humidity, beyond which, I mean, the excess amount of air will just condense out. Right? So that the saturated humidity is very important to determine, and that is based on the vapor pressure of that air. Right? So the vapor pressure, as you know, depends on the temperature. So higher is the temperature, higher is the vapor pressure, right? And naturally the saturated humidity also increases. So based on this idea of the humidity, or this saturated humidity, of course saturated humidity also depends on the total, I mean the overall air pressure, but generally for atmospheric conditions the overall atmospheric pressure doesn't change that much, right?
So won't the Antoine's equation be T plus C?
I mean it depends what is the sign of that C, isn't it? You can write plus, you can write minus, whatever. But it all depends on how, I mean, if you choose it to be plus, then C becomes a negative quantity. Again, same for B. So I just got in my notes, for water, this expression is 12 minus 3985 by T minus 40, something like that.
Be log P as far as I know. Log P is equal to A minus B by T plus.
Log P? I mean, whatever, you know about the Antoine equation better than me, right? So I leave it this to you, but this Antoine equation is can be one way of finding out the vapor pressure of, you know, this vapor content in at a particular temperature. Of course, you can look into some other charts also to quantify this, vapor pressures. So Antoine equation is one way to estimate this vapor pressure, but this knowledge of the vapor pressure, or this vapor pressure as a function of the temperature, is important to find the saturated air humidity. Okay. So now saying this, so what does it mean that the humidity levels at the saturation condition depends on the temperature as well as the air pressure also, right? Because this PT is determined, I mean, affects the saturated air humidity. Now, if we are able to quantify this, you know, saturated air humidity, there are two important, I mean, and this vapor pressure of the air also, there are two important, what should I tell, terms that I would just like to highlight. One is the percent humidity. So the percent humidity is defined as the humidity with respect to the saturated humidity, of course, multiplied with 100. Right, and you can do it in terms of mass, you can do it in terms of mole, doesn't matter. So percent humidity, I can clearly see that this gives a idea about how much is the present humidity levels, or the relative, I shouldn't say relative humidity, there's a different term altogether, how much of the humidity with respect to the saturation humidity conditions the air has reached to, or air has the capacity, right? Because why this percent humidity is so important to know, is because always you may not be knowing what is the saturated humidity, what is the saturation humidity level that is possible at this particular temperature, right? So even let us say you calculate your humidity to be getting as 0.02 kg of water vapor in per kg of dry air, but that doesn't gives too much of an information, rather than saying if the percent humidity is 80%. So we know that the present humidity levels is close to 80% of its saturated value, right, at this present conditions. So that gives a more realistic sense about how humid is the air. Another important terminology is the percent relative humidity. Relative humidity is generally defined as in terms of the relative vapor pressures. Of course, percent relative humidity doesn't give you idea about how much it is close to the saturated condition, but it gives you the ratio of the partial pressure of the air with respect to the vapor pressure of the air. So that also to some extent gives you an idea about that how much of the air is close to saturation, but this doesn't gives you an explicit idea about what is the current moisture content of the air. It gives you an indirect feel about the degree of saturation, that based on the partial pressure value, that how much it is close to the vapor pressure at this condition, right? So at the fully saturated condition, both percent humidity and relative humidity both will reach to 100%, right? That I think is quite implicit now. Okay, so we will stop here for today. Let us not overburden ourselves on the first day. Just one concluding thought. I just all of you want you to think about it as we go to the next class. Like, what is the difference between a gas and a vapor? It is not directly a mass transfer question, but it's quite intriguing to understand at this point that what is the difference between a gas and a vapor? Is vapor really a gas? Under what circumstance can we call a gas to be a vapor? Sorry, vapor to be a gas, right? Why is water vapor a vapor and not a gas, even though it is not present in the liquid state? Isn't it? Is vapor a completely a different thermodynamic state? Please think about this, and we will have a we will discuss more in the next class. And I would really want to hear your views, because this is a very I shouldn't call it, it's not a very clear idea that has been established, but it is something that also sometimes feels quite obvious or intuitive. So how do we explain this? How do we explain something which is a gas and which is not a gas, which is a vapor? Like, what is the really the fine line between these two, right? Thermodynamically speaking, of course, right? Because here we are dealing with a vapor component in a gas stream, right? That's the reason why I raised this point. So please think about this. The more you think, I hope the more you will be fascinated to find out. Okay, so any questions related to what we discussed today? Anyone? No? Come on, guys, all of you are not shy now. I want all of you to be more interactive.